Okay, hello people. This is our second attempt at making this work. Give me a second. I'm hoping we're gonna see some success this time. Here we go. All right, cool. All right, I think we're starting to look a little Gucci. Okay. Okay. All right, hang tight. Let's get Desmos pulled up here, and then we're gonna be Gucci. Let's see if I can do this while we're in a window. Desmos graphing calculator. Okay, and like I said in many videos before, if you're just now entering the video, that's fine. You can fast forward this video until you see me right on the screen. That will let you know when I've actually started working problems. I'm getting some things set up right now. Whoa. Oh, that would explain a lot. Okay, this keyboard is bugging out. All right. That's great. Good God, that's real. Graphing calculator. There we go. All right, cool. All right, so now we have everything we need. Okay, peeps. All right, now we're ready. Okay, and then I can just alternate between these videos as needed, or these windows as needed. Okay. All right, peeps. Okay, so here's what we're going to do. Let's put that away for now. Let's just talk about what's going on. All right, so we're going to talk about graphing functions. I know this might be a little intimidating, but you got this. Okay, we're going to take it piece by piece. So let's get started. Here we go. Graphing. I'm going to put in our writing so those of you who fast forward, you know to start here. Okay? All right, so we're going to be graphing functions. Okay, so first and foremost, at the end of the day, when you need to graph a function, all you're really doing is putting in a value and getting a value out. Remember, so far we've talked about x and y, right? Like if you have 2 and 1 and 0 and 0 and -2 and 1. Okay, those are all, this is an input, this is an output, input, output, input, output. And remember, so far we've talked about even identifying functions, like how do you tell if it's actually a function? And so you would look at this, make sure there's no jealous x's, make sure each x has the same y. So this 2 goes with 1, and this 2 only goes with 1. This 2 doesn't go with 1 and 0. It goes with just 1. Remember that? And so we have 0 and 0. And this one we have -2 and 1. Remember, we also talked about it doesn't matter that both of these guys are going with 1 because it's 2 different x's, so no big deal. All right? Hopefully all of that is memory at this point. Okay, so cool, no big deal. All right, well, it turns out these points are actual points you can put on a graph. So let's graph this real quick before we go into talking about what you would do with functions and finding points, especially for these graphs you've never seen before, okay? Let's just go over some graphing basics, all right? Let's stick this bad boy over here. First, remember that on a graph, this tall axis here, this one that goes straight up and down, let's see if we can get a straight line here. There we go. This tall axis, here, let me go ahead and highlight it here for you. This tall axis is the y-axis. Okay, this is the y-axis. And remember that this longer axis here is the x-axis. That's your x-axis, okay? If this is helpful, for those of you who have a hard time remembering which one is which, think about a railroad, think about a train. You know, like a train often has like an X to signal that it's crossing. And most times when you see a train, it's going from left to right. Because most times when a car pulls up to a crossing, the train isn't heading their direction. Sometimes it can be, actually, but most times the train is going from left to right across your view. So the x-axis is always the one that's going left to right, okay? This is very important to remember because later on I'm going to be teaching you guys about domain and range. And looking at a graph strictly from left to right or strictly from up and down will help you a lot in terms of determining which one is which. But fine, let's bring it back on task. Y-axis is up and down, x-axis is left and right, okay? All right, so fine. You got your x going left to right, you got your y going up and down. Let's then go ahead and put these points on a graph, okay? So we've got 2 for the x-axis, so I'm going to go over here to 2. All right, here's 2. And then this also says to go up 1 because that y is up and down, remember? So I'm going to put my actual point at 2 and then go up 1. So my actual point goes right here, okay? For many of you, this will feel basic, but remember, we're going to go low and slow. This is your basics of graphing, okay? Your actual point is right here where I put this here. Let me put it in green. This right here is 2, 1, okay? All right, fine. Now let's put our next point. 0. Okay, so let's go to 0, which is right here in the middle. Here, I didn't put any of these lines down there. And then it also says to go up and down 0. So you don't go anywhere. So you stay in the middle. So 0. So this point right here is 0, 0. I want you to embrace the idea that you can read these coordinate points as an address because it's really just telling you how much to go left and right, how much to go up and down. When I see 0, 0, what I'm seeing is don't go left and right at all. Don't go up and down at all. Stay in the middle. That's why we are at 0, 0 here. Okay? Our next point, and here, go ahead and give me a pause to see if you can figure it out. Unless you already know graphing, then you're okay. See if you can figure out where we're going to start for -2. Okay? It's on the x-axis. See if you can put your finger where we're going to start. Okay? Hopefully you got we're going to start at -2, which should be right here. Okay, this is -2. So on the x-axis, we're going to go -2. -2 is left. And then our next set of directions say to go up 1. That's what this 1 here on the y-axis means. So we're going to go up 1. So that point should be right here. Okay, this point right here is -2 because we went to -2 on the x-axis. That's this one right here. And then we went up 1 on the y-axis. Okay? When we're ready to graph, we simply take our points and connect them. Okay? Now, whether or not this is actually a V or not, we'll talk about that another time because this could just as easily be a parabola. But the point is, you're going to take those points and connect them. And ta-da, that is graphing basics. Okay? If you need additional help with graphing, okay, if this part right here was kind of irky, okay, when we get tutoring opened up, come on and see us so we can help you with graphing basics. Because what you're doing right now with graphing functions is assumes you know what we just did here. If what we just did here felt unfamiliar, please come by and see us so we can help you with graphing. Because you need to be pretty comfortable with graphing in order to do more advanced graphing, which is where we're headed. But hopefully what I just showed you kind of refreshed you on coordinate sets, how to see them as addresses, how to interpret them, and of course how to connect the dots, okay? Now let's move on to some actual problems. So when it comes to these functions, so these more advanced functions, like, first of all, remember when you see the terms like, up here I didn't show you the actual, function up there. But remember that most people are comfortable with seeing like y equals 2x plus 3. Please don't be intimidated. Here, let me write it in a functional form. F of x equals 2x plus 3. All I did was just change it out. That's it. Don't be intimidated. So these basic functions here, you lay them out the same as you would if it were y. Okay? You're going to pick some points. You're going to put them on a graph and just see what happens. So let's do that with this first one. This first example, I said 2x plus 3. Okay? So some of you may remember from linear functions how to tell, this is in y equals mx plus b form. Don't worry about that right now. What I want you to do is do a simple method where you take 3 points. Some of you on your worksheet, it gives you 5 points. More points is better. More points is more accurate. We're just going to do 3 points so that we can keep this video relatively decent in length. So I tell people to pick one positive number, a 0 number, and a negative number. So let's do that. I'm just going to pick, for randomness sake, I'm just going to pick 1 because that's a positive number. So fine, I'll go positive 1. And then I'm going to go ahead and put that 1 in the equation. Okay, so that we can see what the y would be. All right, remember that the y is the output. What the y is for this graph is the same thing as whatever would come out of this, okay? I'm going to do that for 1. So I'm going to come out to the side and solve for f of 1. Why are you doing that, Mike? Where'd the 1 come from? I just picked the 1 at random. Remember, you can do any positive number you want. You could do 2, you could do 3, you could do 4. It does not matter. I'm picking 1 because it's a simple number and it's positive, okay? This is just a technique I'm showing you. It is not the only way to work these. So follow me on this. We're going to pick 1 positive number, 0, and 1 negative number. So let's solve for our positive number. So f of 1 is equal to 2 times 1 plus 3, okay? All I did was I took this 1 and stuck it in here just like we did in our previous videos. So fine, f of 1 equals 2 times 1 plus 3, which is 2 plus 3, which is 5. F of 1 equals 5, okay? So what this means is this 5 needs to go over here, all right? Because that's what we got when we put 1 in for x. When we put 1 in for x, we get 5 out. We put in 1 and we got 5 out. That's why earlier we were talking about this being an output and this being an input, okay? Some of you may have already caught that when you're working these and you see like f of 1 equals 5, that technically your points are literally right there in front of us. Look at this. Those are your points, 1, 5. Let me move it over here so you can see it a little clearer. See it now? 1, 5. It's buried right there, okay? With that in mind, I'm going to work these in the same format so you can see where we're getting each of these points, all right? But that's one of our coordinate points, okay? So fine, that's our positive number. Now we're going to do a 0 number, okay? So remember, I said at the start, we're going to do 1 positive number, we're going to do 1 0 number, and then we're going to do 1 negative number. So let's move on to our 0 number. 0, okay? So f of 0 equals 2 times 0 plus 3, which is equal to 0 plus 3, which is equal to 3. So f of 0 equals 3. All right? Notice that's your coordinate point right there. When x is 0, y is 3. When x is 0 for this function, y is 3. So let's go ahead and put that in our chart. Okay? Why are we building a chart? So that we have at least 3 dots to connect. As you get into more advanced math, 1 dot doesn't tell you what you need to know to graph it. 2 dots doesn't really tell you what you need to graph it. 3, frankly, isn't going to always tell you either, but 3 is a decent starting place, okay? 5 is really the safer answer, but I'm showing you 3 tonight for simplicity, okay? So fine, let's do our negative number. Let's do negative 1, all right? So when x is negative 1, we have 2 times negative 1 plus 3. Negative 2 plus 3, which equals 1. When x is negative 1, y is 3. Or sorry, when x is negative 1, y is 1. Ha! Shh. Y'all see the math right here, though, okay? This is why you always show your work, okay? I'm mildly dyslexic, so stuff comes out like this all the time, all right? So fine, negative 1. Let's put a 1 here, okay? These are the 3 points we're going to work with for this graph. So now let's graph it. Let's use a different color. Let's put our dashes on here so it's easier to see for you. Okay, if you don't need the dashes, that's great. It's going to save you time. I usually don't use dashes, but I want us to all have a nice visual. Okay, you do not have to use dashes though, and that will save you time on a test as well as energy. All right, so fine. Let's go. Let's read our directions. Our directions say to go to the right one. How do you know it says right, Mike? Because I'm on the x-axis, and remember the x-axis goes left to right. So we're going to go to the right 1. And then we're going to go up 5, okay? Because on the y-axis is up and down. So we're going to go 1, 2, 3, 4, 5. So we're going to be right here, okay? Now on your paper, I don't recommend you do dots when you do this. I'm just showing you dots because we're virtual. On your paper, on your physical paper, you can just hover your pencil or your utensil over each one so you can count it. Count it slow, go low and slow. A slow correct answer is better than 5 fast wrong ones, okay? 0 and 3 is our next point. So let's start at, we didn't mean to erase that. Let's start at 0 on the x-axis, which is right here. And then let's go up 1, 2, 3, because our direction is so to go up 3. Remember, y-axis? So our second point goes here. All right? And now for our last point, this starts to start at -1. So I'm going to go over here to -1, and then I'm going to count up 1. Okay? Let's highlight those green so we can see it apart from our counted dots. All right, and then we simply line them up. Now, I don't think I have a ruler in this app. I sure don't, but that's fine. I'm just going to do my best to line them up here for you. Okay, not exactly the straightest. There we go. That's a little better. Still not quite 100% accurate, but close enough. All right, there is our graph, a nice straight line. And that makes sense for some of you who remember this from the end of 7th grade. This is a linear function. You can tell because the x here is just an x. It doesn't say square. It doesn't say cube. It doesn't say square root of x. It just says x. Because the highest power on this x is 1, I'll put a little 1 here. We know it's linear. Now, if that last part there confused you, completely ignore it. For those who can catch it, that will help you identify if something's linear or not just by looking at it. But for those of you who that confused, don't worry about that last note. The point is, when you see an x right here and there's no exponent on it, so it does not say x squared, does not say x cubed, does not say fourth, x to the fifth, it doesn't have any little number next to it, and it doesn't have any of this on it, and it's not like this. If it's just x, it can have a regular number in front, that's fine. But as long as that x isn't doing something crazy like being on the bottom of a fraction, or having an exponent on it, or having a bar over it, okay? Or, for those of you who are a little more advanced, got some trigonometric function on it, unless it's one of those, it's gonna be a nice straight line, okay? So let's get rid of all of that, because we're coming to it soon anyhow. All right, so this is a straight line. Anytime you see that x without an exponent on it, it's going to be a straight line, okay? Let's have a look at Desmos real quick so you can see that, and then we're going to move on to our square graphs, because a lot of this worksheet that you got today was simply being able to A, put stuff in Desmos or graphing calculator, and B, recognize what different graphs about look like, and then C, be able to pick out points on a graph. So I'm going to start you by helping you see what graphs look like, and then I'll show you how to find those points. All right, so let's do that real quick. Here's Desmos. Let's put in 5x. So I'm going to type on the keyboard. Whoa, okay, this keyboard is bugging out. Okay, yeah, no. Oh, God. Okay, hang on. I'm going to, whoa, that is a biggie. All right, y'all hold on 1 second. I got to fix that. That's not going to work. Did it stop? Okay, yeah, I think it stopped. Is it? All right, but I can't move the mouse now, so